Good morning to you all. Now comes thermochemical equations. Okay. Here in thermochemical equation, this is nothing but it is a balanced stoichiometric chemical equation that includes the enthalpy change. So here we all know stoichiometric equation apina nana reactant number of moles and then product number of moles that gets balanced. They both get balanced. Other than our stoichiometric chemical equation episode. See here the following conventions are adopted in thermochemical equation. The coefficient in a balanced thermochemical equation. So இதெல்லாம் வந்து பாத்தீங்கன்னா the different conventions of thermochemical equations. Here the coefficient in the balanced thermochemical equation that refers to the number of moles of the reactant as well as the product which is involved in the reactions. Here the coefficient, for example coefficient அப்படின்றது நம்ம 1 mole அப்படி சொல்றோம். 1 mole அப்படின்றதுல அந்த 1ன்றது அதோடைய coefficient. 1 mole of water அப்படி சொல்றோம். அப்போ வாட்டரோட coefficient வந்து எவ்வளோ இருக்கு 1 இருக்கு. அதுதான் coefficient அப்படி சொல்றோம். Here the enthalpy change of a reaction that is simply represented by delta HR. Delta HR refers to the enthalpy change of a reaction. Now, when the chemical reaction is reversed, the value of delta H is reversed in sign with the same magnitude. Okay, when it gets reversed means then the value on the reverse side. Then the physical state of all the species are important and must be specified in a thermochemical reaction. Since delta H that depends on the physical state of the reactant and product. Okay. So here physical state அப்படின்னு சொல்றோம் அப்படின்னா physical stateன்றது gas இருக்கலாம் liquid solid என்ன வேணாலும் இருக்கலாம். Okay. So that we are naming as like that. Here this depends on the physical state of reactant as well as the product. It's a thermochemical equation வந்து நம்ம multiply பண்றோம் throughout by a number. The enthalpy change is also multiplied by the same number. So reaction நம்ம எவ்வளோ number multiply பண்றோமோ அந்த throughout reaction we have to follow the same. So thermochemical equation அப்படின்றதுக்கு இந்த steps எல்லாம் இருக்கணும். The negative sign of delta HR. So delta HR னா என்ன இங்கே நம்ம பார்த்தோம் enthalpy change of a reaction. That the reason that the reaction is exothermic and the positive sign of delta HR indicates an endothermic reaction. Okay, so negative sign means that refers to exothermic. So positive sign means that refers to endothermic reaction. Now comes the heat of combustion. The heat of combustion of a substance is defined as the change in the enthalpy of your system when 1 mole of the substance is completely burned in excess of air or oxygen. Okay. The change in enthalpy of the system when 1 mole of the substance is completely burned in excess of air or oxygen. So heat combustion அப்படினாலே நம்ம கலடுக்கிறோம் that takes place in the presence of air. So oxygen especially நம்ம சொல்லணும். So and the change தான் நம்ம என்ன சொல்றோம் heat of combustion அப்படி சொல்றோம். So the change is represented by the symbol delta H C. This C refers to combustion, H refers to the change of enthalpy. Okay. So நம்ம சிம்பிளா இந்த ஃபார்மை வச்சு நம்ம ஒரு டெஃபினேஷன் ஃப்ரேம் பண்ணலாம். Here if we take an example, methane. So methane எடுத்தோம்னா values வந்து பார்த்தீங்கன்னா it is equal to minus 87.78 kilojoule per mole. Now comes molar heat capacities. Here in molar heat capacities, when heat is supplied to a system, the molecules in the system absorb the heat and hence their kinetic energy increases, which in turn raises the temperature of the system from T1 to T2. So T1, T2, and I'm already the initial temperature and then final temperature. So their change is simply T2 minus T1. So that is directly proportional to the amount of the heat absorbed and the mass of the system. Here you can see the example for a thermochemical equation. So thermochemical equation is here you see that refers to standard enthalpy of enthalpy change of a reaction that one வந்து ப்ராடக்ட் இன்னொன்று வந்து ரியாக்டன்ட். ஸோ ப்ராடக்ட்லேருந்து நம்ம ரியாக்டண்ட்டை மைனஸ் பண்ணுறோம். ஸோ ஏதோ ஒரு ரியாக்ஷன் ஜென்ரலாக ஏஏ ப்ளஸ் பிபி வில் கிவ் சிசி ப்ளஸ் டிடி. ஸோ இப்போ இதில் எடுத்திங்கன்னா this will be given by delta H naught or will be equal to C. So product order value substitute பண்ணுறோம் and then next reactant order value substitute பண்ணுறோம். Okay, so that only we are mentioning like this. Here you see another example for this heat of combustion. See here in heat of combustion also you see methane along with oxygen. So that we are getting carbon dioxide plus water. Here you see carbon and then oxygen that leads to give carbon dioxide. That is simply delta Hc. Then comes molar heat capacities. When heat is supplied to a system, molecules in a system absorb the heat, and that we discussed as earlier. See here, their change only we are simply representing as Q is proportional to M delta T. So M that refers to mass, delta T is simply the change in temperature, T2 minus T1. So now Q will be equal to C M delta T. So now we have to rearrange this. C into another constant that will be given by Q by M delta T. Q refers to heat. So now this will be given by Q by M into T2 minus T1. So finally we can tell C will be equal to Q. That is because the value of T2 minus T1 is 1 and M also 1. So when you 1 we are getting C will be equal to Q. Right? See here now comes heat capacity. So heat capacity for 1 mole of a substance is called molar heat capacity. Simply we can tell Cm of this molar heat capacity அப்படின்றது Cm. So the amount of heat absorbed by 1 mole of a substance to raise its temperature by 1 Kelvin. So this is given by the definition, the standard definition as like this. Now, the unit of heat capacity, SI unit is simply, we can tell SI unit of molar heat capacity is joule per Kelvin, joule per Kelvin per mole, joule per Kelvin per mole. Here CV refers to constant volume, CP refers to constant pressure. Okay. So now U will be equal to Q plus W. U will be equal to Q minus P dV. So dV is simply delta V. So now Q will be equal to U plus P dV. Here we all know the value of W is minus P dV. That only we have substituted here. So இது நம்ம என்ன பண்றோம் Q U in the side கொண்டு போயிட்டு Q வந்து we are bringing back to this side. So which means on rearranging we are getting this minus to become plus. So now on differentiating both the equation dou Q by dou T with respect to volume, dou U by dou T with respect to volume. Now we can tell CV will be equal to dou U by dou T. That takes place at constant volume. Here the heat capacity at a constant volume CV is defined as the rate of change of internal energy with respect to temperature at constant volume. அதே மாதிரி the constant pressure is simply Cp, which is defined as the rate of change of enthalpy with respect to the temperature at constant pressure. Here this dou Q that refers to enthalpy, that is H refers to enthalpy, T refers to temperature. So the change of enthalpy with respect to temperature, this takes place at constant pressure. Okay. So that's all about this heat capacity and then their unit. So actually this is an important question. So CV அப்படின்றப்போ we have to keep the volume constant, that is differentiate with respect to volume. Here for CP we have to differentiate with respect to pressure. Okay. Here now comes the relationship between Cp and Cv.